Welcome to our deep dive, everybody. We're taking a journey to the polar regions, virtually of course, to explore the science behind those dazzling auroras.
A celestial spectacular.
And we're going to illuminate the mysteries behind these dancing lights using insights from a Wikipedia article all about auroras.
Auroras are a great topic. They've fascinated people for centuries, scientists, and just, regular sky watchers alike.
Absolutely. So let's dive right in. The source we have today describes auroras as dynamic patterns of light, like curtains, rays, even spirals, all painting the night sky. It sounds so incredible. What exactly causes these mesmerizing displays?
Well, at their core, they're a natural light show. They happen when charged particles from the sun interact with Earth's magnetic field.
Okay.
And they're most commonly observed in high-latitude regions.
Ah, the famous northern and southern lights. I've always wanted to see them.
Yeah.
The source mentions that they can sometimes even be seen at lower latitudes, though. What kind of conditions would cause that?
That's where geomagnetic storms come in. Picture the Earth's magnetosphere as this giant protective bubble.
Okay.
It shields us from the constant stream of charged particles coming from the sun, which is called the solar wind.
Oh, right, the solar wind.
Yeah. So during intense solar activity, this protective bubble gets distorted, and some of those particles get funneled toward the poles, traveling along magnetic field lines.
So the Earth's magnetic field acts like a shield, but also kind of like a guide for these particles.
Exactly. When these charged particles, mainly electrons and protons, collide with atoms in the Earth's upper atmosphere, they transfer energy and cause those atoms to get excited.
And that's what makes the glow. The source mentions that different colors of the aurora appear at different altitudes. What causes this variation?
Well, different altitudes have different atmospheric compositions.
Oh, right.
So, for instance, when oxygen is excited at higher altitudes, it emits red light. But lower down, that same oxygen, when excited, emits green light.
Wow, so it's like a giant atmospheric chemistry experiment is playing out above us.
Yeah, you could say that. And nitrogen also plays a role, emitting blue, purple, and even red light, depending on the type of interaction. This blend of elements and altitudes is what creates that stunning array of colors.
That's fascinating. I had no idea there were so many factors at play.
Yeah.
The article also mentions different forms that auroras can take. Glows, patches, arcs, rays, even coronas.
Right.
What determines these shapes?
Those forms are shaped by the geometry of the Earth's magnetic field, and the viewer's perspective has an influence as well. Like imagine you're standing directly beneath a curtain-like aurora.
Right.
From your position, you might see a magnificent corona, a crown of light radiating outwards.
Oh, wow. It's incredible how perspective and those charged particles interacting with the magnetic field create these unique forms in the sky.
It really is. And there are also some unusual types of auroras that have scientists really interested.
That's where it gets even more interesting. The article mentions Steve, picket fence auroras, dune auroras, even horse collar auroras. They sound otherworldly.
They do, don't they? Let's start with Steve. While it's often mistaken for an aurora, it's actually a distinct phenomenon. It's caused by hot plasma in the upper atmosphere and appears as this narrow purple ribbon of light.
So Steve is like a glowing river flowing through the upper atmosphere. What about these picket fence auroras?
Picket fence auroras, well, they're named for their resemblance to a picket fence. They appear as vertical green stripes, and they often accompany Steve, suggesting a link between these two phenomena.
It's like a cosmic light show with special effects. What can you tell us about the other unusual types, like dune and horse collar auroras?
Dune auroras are a relatively recent discovery. They have these wave-like patterns that resemble sand dunes. Scientists believe they are caused by variations in the density of atomic oxygen in the atmosphere, likely influenced by atmospheric waves.
So it's not just particles from the sun. Earth's atmosphere also plays a role in shaping these displays.
Absolutely. And then there's the horse collar aurora. It's a rare form observed during those extremely intense geomagnetic storms. It appears as this bright oval-shaped band with a darker collar region inside.
Interesting.
Its formation is still being researched, but it's thought to be related to the very complex dynamics of the magnetosphere during these powerful storms.
It's fascinating how much we're still learning about these seemingly familiar auroras. But it's not just Earth that puts on these dazzling displays, right? The article mentions auroras on other planets. What makes them similar or different from the ones we see on Earth?
Yeah, you're right. Auroras have been observed on several planets in our solar system. Their characteristics can differ depending on the planet's magnetic field strength and atmospheric composition. For example, Jupiter, with its very powerful magnetic field, boasts auroras that are far more intense and larger than Earth's.
Wow, that's incredible. What about other planets? Are they all similar to Jupiter's auroras?
Not necessarily. Mars, for instance, has a very weak magnetic field.
Okay.
So its auroras are much fainter and more localized. And then you have Venus. Venus, despite lacking a global magnetic field, has shown some evidence of auroral activity.
Really?
Yeah,
So there might be other mechanisms at play there.
it seems so.
It's amazing to think that these beautiful light shows are happening all across our solar system, each one with its own unique twist.
It really is. But the story of auroras extends beyond just their scientific explanation. They've captured human imagination for centuries and have led to a lot of diverse cultural interpretations.
Oh, that's right. The article mentions some really fascinating examples of how different cultures have viewed auroras throughout history. What are some of those interpretations?
Well, for instance, Aboriginal Australians, when they observed auroras low on the horizon, predominantly with red hues, they often associated them with fire.
That makes sense given their appearance. What about other cultures?
The Maori of New Zealand viewed the Aurora Australis, the Southern Lights, as like a celestial manifestation of their ancestors who had sailed south. A beautiful link between the earthly and the celestial.
It's incredible how these natural phenomena have been woven into the fabric of different cultures.
Absolutely. And in Scandinavian cultures, there were tales of auroras being vast fires surrounding the ocean, or glaciers storing energy and glowing with this sort of ethereal light.
It seems every culture has found its own unique way to explain and revere these captivating displays.
They really have.
We've covered so much ground already, from the basic science to cultural interpretations.
Yeah.
But there's one more thing I'm curious about. The source mentions the Carrington event of 1859, the most intense geomagnetic storm ever recorded.
Oh, yeah.
What happened during that event, and what makes it so significant?
The Carrington event was, it was remarkable. It caused auroras to be visible as far south as the tropics. Imagine that.
Wow, that must have been an incredible sight. But what makes it so historically significant?
Well, the Carrington event's significance lies in its impact on technology. Even back then, it severely disrupted telegraph lines across the globe. Some even caught fire.
I can't imagine the chaos that must have caused back then.
It was major. And it revealed this powerful connection between auroral activity and electricity. Some telegraph operators were even able to communicate using the auroral current.
No way. So they essentially harnessed the power of the aurora to send messages.
Exactly. It was a remarkable testament to both the power of the aurora and to human ingenuity in adapting to such unforeseen circumstances.
So the Carrington event wasn't just a beautiful spectacle. It was also a wake-up call to the potential impact space weather can have on our technology.
Absolutely. And that's why scientists today are actively studying space weather to better predict and mitigate the effects of similar events in our increasingly technology-dependent world.
That's a really crucial point. We've come a long way since 1859, and our reliance on technology has grown exponentially.
For sure. The Carrington event serves as a stark reminder of our vulnerability to those powerful geomagnetic storms. Imagine the disruptions a similar event could cause today, with our dependence on satellites, power grids, and global communication networks.
It's a sobering thought. It seems that while we've uncovered many of the secrets of the auroras, there's still much to learn,
Yeah.
especially about their potential impact on our modern world.
You're absolutely right, and that's what makes studying auroras so compelling. They give us a glimpse into this complex interplay between the sun, the Earth's magnetosphere, and our atmosphere. It reminds us of the interconnectedness of our planet with the cosmos.
And they highlight the importance of continued scientific exploration to understand and prepare for the potential challenges and opportunities presented by these celestial wonders.
Right, exactly. But for now, I think we need to take a break, and we'll continue our exploration of auroras in the next part of our deep dive.
Sounds good to me. I can't wait to delve even further into the mysteries and marvels of these displays.
Ready to jump back into those auroras?
Oh, absolutely. Last time we were talking about the Carrington event and how it impacted even the limited technology back then.
Right.
Makes you wonder, what other mysteries are scientists still trying to figure out about these celestial displays?
Well, one of the big questions is about the nitty-gritty of how those charged particles are accelerated and how they interact with the atmosphere to make those incredible light shows.
So even though we get the basic idea, there's still a lot we don't know about the finer details of the whole process.
Exactly. It's like we have the recipe, But some steps are missing. Scientists are still working to understand how those particles gain enough energy to excite the atmospheric gases and produce those vibrant colors.
Yeah. It's a good reminder that even things as seemingly familiar as auroras still have these hidden
You
complexities.
really do. And then there are those rapid changes in color, intensity, and form that we often see.
Oh, right. Those dynamic shifts are part of what makes auroras so captivating. What are some of the leading theories about what causes those?
Well, scientists think that fluctuations in the solar wind, changes in Earth's magnetic field, and even interactions with atmospheric waves all play a role.
Hmm,
It's kind of like a cosmic symphony with all those different elements contributing to the overall performance.
that's a great way to put it. And of course, we can't forget about auroras on other planets.
Right.
We
Right.
talked about them a little earlier, but there's so much more to explore. What are some of the key differences between auroras on Earth and those on other planets?
As we mentioned, Jupiter has those really strong magnetic fields,
Right.
so its auroras are far grander and more intense than Earth's.
But what about planets with weaker magnetic fields, like Mars or Venus?
Yeah.
Do those planets have similar auroral activity?
Auroras have been observed on both Mars and Venus, although they're much fainter and less frequent.
That's surprising, especially since Venus doesn't have a global magnetic field.
Exactly. It suggests that other mechanisms might be at work, maybe interactions between the solar wind and Venus's thick atmosphere.
Hmm. It's interesting how auroras aren't just limited to planets with strong magnetic fields, and it seems like there's still so much to learn about how these phenomena happen in different environments.
Oh, definitely. Each planet is like its own laboratory for studying auroras and how the solar wind, magnetic fields, and atmospheric composition all work together.
And can those extraterrestrial auroras help us understand the processes happening on Earth?
Oh, for sure. By studying the similarities and differences between auroras across the solar system, we get a broader view of the physics involved.
Okay.
We can better understand what factors influence their characteristics.
It's fascinating how studying auroras can connect us to these distant worlds while also giving us a deeper understanding of our own planet.
Exactly. That's part of what makes this field so exciting. Every new observation, every piece of data adds to our understanding of these incredible displays.
Speaking of adding to our understanding, there's one more aspect I'd like to discuss. We've talked about the science and the cultural interpretations, but what about aurora's impact on our modern world?
Yeah, that's a crucial question, especially these days when we rely on technology so much.
The Carrington event showed us how these geomagnetic storms can mess with technology. Even back in the 1800s, what kind of consequences could those events have in today's world?
Well, a major geomagnetic storm could cause big problems. It could disrupt power grids and cause widespread blackouts.
Oh, wow.
Critical infrastructure could be affected too.
That sounds really worrying. What about communication systems? Would they be affected as well?
Oh, absolutely. Satellites, which we rely on for communication, navigation, and all sorts of things, are very vulnerable to space weather.
So a bad geomagnetic storm could basically shut down our communication networks.
It's definitely a real possibility, and it's something scientists and engineers are working hard to address.
It seems like the stakes are even higher now than they were back during the Carrington event.
Definitely. The potential impact of space weather on our interconnected world is a major concern.
What are we doing to reduce these risks?
Well, scientists are always keeping an eye on solar activity. They're developing forecasting models to predict those geomagnetic storms.
So hopefully we'll have some warning if something's headed our way.
Exactly, that's the idea. And engineers are working on building more resilient infrastructure, like satellites and power grids, that can handle the effects of space weather better.
It's good to know that we're taking these potential threats seriously.
Oh, absolutely. While we can't eliminate all the risks, understanding and preparing for space weather is essential. That's how we keep our technological world running smoothly.
It's a reminder that even though we're in awe of the beauty of auroras, we also need to be aware of their potential power.
Well said. Auroras show us how connected Earth and space are, and they remind us of both the beauty and the potential challenges of our place in the cosmos.
It seems like we've covered a lot, but there's always more to learn about these fascinating phenomena.
Oh, absolutely. Auroras are always fascinating and challenging scientists. They reveal new insights into how our planet works and what's going on in the universe beyond.
It's really amazing how auroras bridge the gap between what we know about science and the mysteries we're still working on. What are some of the biggest questions researchers are trying to answer right now?
One area that's really hot right now is the connection between auroras and space weather.
Uh-huh.
Scientists want to get a better grip on how those geomagnetic storms impact Earth's upper atmosphere and how those changes affect auroral displays.
So it's not just about predicting when and where auroras will happen, but also understanding how they change in response to those dynamic space weather
You
events.
got it. By studying those correlations, we get valuable clues about how the sun, Earth's magnetosphere, and our atmosphere interact in such a complex way.
And then we can use that information to improve our forecasting models, right?
Yeah. Right.
And protect our technology from potential problems.
Exactly. Another really cool research area is studying auroras on other planets to see how they compare to the ones on Earth.
We talked about that a bit before, but what specific questions are scientists hoping to answer with these studies?
Well, for example, Jupiter and Saturn have way stronger magnetic fields than Earth.
Right.
By looking at their auroras, we can learn more about how the intensity and shape of auroras are affected by a planet's magnetic field strength.
So those giant planets are basically natural labs for studying auroras in extreme conditions.
Exactly. And comparing Earth's auroras to those on Mars, which has a very weak magnetic field, can teach us about the role of planetary magnetic fields and how auroras form.
It's incredible how each planet offers us a new perspective on this phenomenon and helps us understand things beyond our own planet.
Absolutely. And as we get more data from spacecraft missions and observations from Earth, we keep refining our models and theories about how auroras work.
It sounds like the study of auroras is always changing and full of new discoveries and challenges.
It definitely is. And it's a field that brings together people from all sorts of scientific backgrounds:
Mhm.
physics, astronomy, atmospheric science, even computer science.
That's a great example of how scientific exploration requires people from many different fields to work together.
Couldn't have said it better myself. As we continue to learn more about auroras, we're not just expanding our knowledge of science, we're also gaining a deeper appreciation for the beauty and wonder of our universe.
It's a good reminder that science isn't just about facts and figures. It's also about the awe and inspiration we feel when we understand the natural world.
I totally agree. Auroras give us a glimpse into how the cosmos works, making us curious and pushing us to explore the unknown.
Well, I think we've covered a lot of ground in our deep dive into auroras, from the basic science to what they mean to different cultures and the research that's still going on. It's been an incredible journey.
It really has, and I hope it's made you want to learn even more about these captivating displays.
If you want to know more, there are great resources online, including live aurora webcams and websites that track auroral activity.
And of course, nothing beats seeing an aurora in person.
Right.
If you ever get the chance to travel to a high-latitude region, go for it. It's an experience you'll never forget.
Absolutely. Seeing those shimmering curtains of light dancing in the night sky is something truly special.
Well said. Looks like that's about all the time we have. Thanks for joining us on our deep dive into the world of auroras.
Until next time, keep looking up and let the wonders of the universe inspire you.